Hello guys, good evening. Welcome to our channel. I hope you are all doing good. Yeah. In this video, we are going to discuss about how to develop our own inverter from scratch. Why I chosen this topic is in today's world, most of the cases, renewable energy is getting a lot. It's most of the places it is more people are aware of this renewable energy. Some people are using rooftop solar, some people are using small windmills in remote areas for bringing water or some other purpose, for light also. Yeah, it depends. Worldwide we can say almost 50% renewable energy is going to be happen in near future. So renewable energy, say for example solar energy, which is most leading in renewable energy sector. uh, it is generated through photovoltaic cells. That is the voltage or power, the current or whatever it is generating, it is DC in nature. But but we can't transmit the DC directly through our transmission lines. That is the DC transmission is outdated in initial phase of the electricity itself. So we have to convert that into the AC form. So for converting this supply from DC to AC, we need one converter in between them. So we can say that as an inverter, which translates from DC to AC. So this project this is actually a very big project. In a single video, it is not possible to discuss everything about how to make complete inverter. So uh, this is my BTech project. So I'm just going to discuss that. This is in this video I'm just presenting the result. I mean the input and the final output result. What are the components? How we can choose a rating of the components? What are the varieties? Remaining all in next upcoming videos, I'm going to make those videos like part 1, part 2, part 3, like that. Yes, for this in this video, I'm just going to discuss few basic things only. Yeah, this is the my BTech project abstract. I'm just going to read it. Design of PWM inverter for induction motor drive applications. Yeah, in this case, you just forget about induction motor. Only thing we need AC from DC. That's what the inverter is going to do. There are so many techniques for a single phase inverter, three phase inverter, for making the pulse single to DC to AC. It can be like what I can say. It can be like a single step. For example, AC means it will be like this. DC means it will be like this. For converting this DC to AC, we can make like this is also AC. Some people will say stepped wave. This is also AC. Some people will say this is also AC, something like that. So there are so many AC available. For example, in this case we have many harmonics. In this in this case, many harmonics. We have many harmonics. I mean, other than 50 hertz, we have different harmonic frequencies, which is framing the total bunch of supply. So, how we can convert from this available DC to AC? That's what we are going to discuss. Yeah, this is simply an abstract. Voltage source inverters are most widely used power converters for induction motor drive applications. The pulse width modulation technique are employed for control of output voltage and frequency. In real time, these pulse width control signals are generated from a dSpace DSP based 1104 control kit. The control signals are obtained from dSpace kit are of less than 5 volts. The strength of these signals are not sufficient to turn on switches IGBTs that are present in the inverter module. A voltage pulse of minimum 10 to 15 volts is needed for turn on of IGBT switch. Moreover, switches on same leg needs a firing pulse with a certain amount of delay, else dead short circuit will occur, which is undesirable. This proposed project addresses issues of such a low voltage pulses by boosting it to suitable level 10 to 15 volts, and short circuit protection is provided by delaying the pulses applied to lower switch on the same leg of inverter. Keywords are voltage source inverter, pulse width modulation, driver circuit. Yeah, this is abstract. If you want, if any BTech graduates or any postgraduates or any research fellows want to do any um, project or research on developing an inverter, they can take this as an example, a starting point for their abstract. Yes, this document contains more technical words that should, but yes, I'm going to simplify as much as possible. Yeah, the picture whichever you are seeing on left side, this is me, this is my friend, and Kiran Kumar, uh, Nagarjuna, my another friend. We are batchmates in BTech for mini project. So this is what my project is. Yeah, it is simply nothing but PWM inverter. We are using whatever the components you are able to see here. These are MOSFETs or IGBTs. Whatever the components we are seeing left side, small electronics, capacitors, inductors, resistors, these are all small ones. They are firing circuit for fire triggering the these devices. So we are able to see how the supply is, how the firing pulses are getting generated in this CRO. Yeah, yeah, we can, you can see here we have very small transformers, very small transformers. This we used for supplying 5 volts. This transformer has a center tap at the secondary. Primary is like normal 433 volts. Only 5 volts we need on secondary side, so that's why we used this. For 3 phases we used 3 different one. Yes, yeah, these details I will post in my next upcoming videos, like part 1, part 2, like that. Yes, for time being, this is the supply, how we are generating the three-phase supply from DC. So whatever the three-phase supply we got, the supply we are going to give to induction motor, and we are going to demonstrate how the speed of induction motor is going to vary based on firing angle or pulse width modulation. So that, yeah, we can see it in next video. This is the circuit. Whatever you are seeing here is a DC voltage. It can be from Soalr. Generally you say like Soalr. So this whatever DC voltage is there, we are just connecting some, these are some dead devices, some devices, electronic devices, but their capacities may vary based on the power which we want to convert. Say if it is 1 megawatt power, the capacities may be low. If it is some 20 megawatt power, the capacities may be high. Say this entire arrangement like one unit like this, we may need to connect more units in series if we need more voltage. Otherwise we may need to connect more units in parallel, just to get more current. Yeah, like this. uh, like this, there are different cases. Only thing, number of combinations will be there. We are going to give plus and minus. Just we are going to take AC current from this output. So whatever AC is coming, that's our wish. Say this is first phase, this is second phase, this is third phase. Yeah, we can use for whatever the application, maybe motor or normal for exporting to grid or so whatever it may be. Yes, we can use like this. Uh, whatever to turn on this device, we need some firing circuits. So if it is a diode, it will directly turn on. There is no need of any further firing circuits. If it is BJT, if it is BJT, if it is a transistor, if it is a SCR thyristor, if it is a IGBT, if it is a MOSFET. So latest I think we have GTO, get turn off thyristor. Yes, there are different aspects. We can use any of this device based on our applications. I think transistor, normal transistor, they may use in normal maybe 10 or 20 watts range, but remaining all use it in power range. Yeah, this is the circuit. PWM is one of the technique used for giving pulses to these devices, firing circuits. Uh, One is sinusoidal pulse width modulation. Yeah, there are different techniques are there. Yes, surely we are going to discuss in our next sessions. Hope this video is an initial step to all of you. If you have any doubts or comments, or if you need any further material on this, you can just comment in the comment section. I will go through it and I will upload whatever details you need. That for sure. Yes, based on your comments and all, based on the audience requirement, I'm going to make remaining parts of this video design of inverter. So for time being, this is up to this. This is the we can say full stop for this. Yeah, if you have any questions, you can comment it. Thanks for watching our channel. If you have any other topics, if you need, you can just comment it. Thanks a lot. If you didn't subscribe it, please do subscribe. Thank you. Bye bye.